Okay, hey everybody, how's it going? So let's continue our chapter in array from Brian 75 LeetCode question. So today I would like to finish this array chapter with the last question. I think this is a good one to think about array and how to optimize the solution, which is container with most order. Let's do it. Okay, so we're given an array of integers called height, which is just which we want to represent a graph, a bar graph, and it is not sorted. It is randomly generated. So our goal is to find the maximum area, and I know most of you already know that area can be computed by base times height. And it seems like a tricky part in this question is that we think this area as a container to contain water. So we need to find a minimum of 2 bar because above the minimum, the water is gonna spill out. So we always need to find the minimum height between the 2 bar and then compute the base. So that's the goal. So basically the goal is to find the maximum. As usual, we're gonna start with the goal setting. So goal is to return max area where area equals base time height and base equals we can say, so if we have two index, let's say right minus left, and then height equals to minimum of the array input of left and right. It's very straightforward. Yeah, so that's the goal. What about the constraints? So I always give 3 to 4 constraints because that's usually the case. So first thing we need to think about the edge case. Is empty input possible? And let's see the questions. So constraints is given that length is always bigger than or equal to 2. So no empty input. And then is elements sorted? No, and it actually doesn't matter in this situation because in the solution I'm gonna explain why, but it doesn't matter whether it is sorted or not. But anyway, okay, so how about negative numbers? Negative elements? Do we have any negative elements? So it is given that height is always bigger than 0 or equal to 0. So it is always positive. No. What else? Do we have duplicates? Duplicates? But it doesn't matter in this situation because we're gonna compute the area anyway, and we don't need to. The answer doesn't matter if we have duplicates elements or not. So I'm gonna explain duplicates constraints for now. Okay, so I think we're all set about the goal setting and the constraint setting. So now I would like to spend a few minutes to think about a few ideas. Let's say 1 and 2. So brute force is definitely for each num, run a nest loop. So what I mean is that if we start with 1 and I'm gonna start another loop and then compute the maximum, compute the area for starting point of 1. So 1, 8, 1, 6, 2, 1, 2, 1, 5, 4, 1, 4. So this is gonna take of n squared because we're using using a nest loop inside of for each loop. So this is, I think, too slow. So another case is that I think because this is area, we can use use 2 pointers, and I'm gonna declare left and right. So the point is while left is smaller than right, I'm gonna do 3 things, I think. So let's do to do 1, to do 2, to do 3. So to do 1 is to compute the area. We already have a logic here, so I'm gonna copy and paste later. And then to do 2, it's the update the answer. So this is gonna be max of current answer in the area. And then lastly, we're gonna do the iterative. So move index, move an index, either right or left. So which one should we move? So when height of left is smaller than height of right, what do you think? So in this situation, we have bar 8 and bar 7. What is gonna take the minimum? In the future, we might have a bigger bar than 7, so we might want to check. We might want to proceed to the this right index to the next. So that finally we have a higher bar compared to 7, which is 8. So we can compute the area of 8 and 8. So if we use the greedy algorithm, we should move the index of the smaller height. So in this case, we should start left to the right, and else, which means left is higher than right, exactly this example 1, then we should move the right to the left. So let's do it. By the way, what's the runtime? This is all when, because we only traverse for each element. It doesn't matter 1 pointer or 2 pointers, 3 pointer. We're gonna eventually do the pass of the entire array only once, so it's all when. Yeah, so let's start with declaring answers, and then I'm gonna declare some constants, not the constants, but I'm gonna declare the left index and right index. Start with 0, and then right is gonna be the length of height minus 1. And then while left is smaller than right, So I'm going to do these 3 things. Let's copy and paste. And then at the end, we want to return the answer. So computer area, we already have the idea. Area is base times height. Okay. So we can copy and paste. So we have base, and then we have height, which is the minimum of the 2 bar, like this. So we have area, and then we're gonna update the answer. So answer equals maximum of current answer in the area computed from 1. So that's number 2. What about to do 3? We need to move an index. So use if statement. If left is smaller than right, and then I'm gonna update left, else we're gonna update right index, and then return the answer. So I think this is working. Yeah, so example 1 is passed. What about edge case when there are only two bodies? Yes. And then example 3. This example contains duplicates, but it shouldn't matter because we're gonna check only the area, not the duplicates. Last example 4. Okay. Do we have any other edge cases? I checked that we don't have negative or we don't have empty input, but let's include 0 because 0 is possible. So when there's 0, the answer should be 0. Yes. Okay, so I think I'm gonna submit. Great. So the theory is that runtime is O of n. And what's the memory usage? So we have declared a constant memory answer left, right, and then we have area, which is also constant. So this is constant memory. That's why memory usage is good compared to other solutions. So for runtime of n and of constant for memory usage. Okay, so one last question we might encounter during the interview is that can we do it faster, like of log n? But of log n is usually when we find target from the integers, like using the binary search. Can we use binary search in this case? My guess is not, because even if we have binary search, like computing the maximum height doesn't necessarily guarantee maximum area, because area is also depending on the base, which is right index minus left index. So using the binary search does not find a right answer. So my response is that O log n seems difficult in this case. So I think we can end here. So O n is the optimized solutions compared to a brute force method takes of n squares. So O n is, I think, good solution in this case. Yeah, so that's pretty much it. This question was very good for a concept of understanding using 2 pointers, and then computing the area, updating the answer, and then moving the index as iterative way. Yeah, that's it. Thanks so much.